Hello everyone and welcome back to day 2 of the 100 Days of ML Code Challenge. We'll be going a little bit out of order and jumping into data exploration, but we'll be returning tomorrow to review the CRISP-DM DevOps model, as well as the background project understanding relating to dengue fever. But jumping right into the data exploration, you can see what we've done is load our data from the CSV files that were provided to us into a pandas data frame. Uh, it looks very similar to an Excel spreadsheet, but it's basically a table row column model for our data in the sort of computational matrix that we'll be able to do a lot of operations on. Notice that it stores both categorical data, like the city label, San Juan, as well as the numeric data, such as precipitation, year, and so forth. So after we've loaded everything into the data frames, both the training features, labels, and the test features, what we did actually is do something called pickle this data. So what this does is saves the data as a byte stream object so we can load it up quickly as its own thing rather than having to import from a CSV every time. So what we did here is saved everything as a byte stream object into a new directory, and then we loaded it out. So this is the same data frame that we saw earlier, but it's been loaded from a byte stream object rather from the CSV, so we no longer have to load from the initial CSV files. This is going to save us time and memory in the future as we're working with this data. Looking a little further, we're now begin exploring the data by looking at the summary stats for our labels and features. These are the descriptive statistics for our labels. The year information is not very useful. Well, actually, we do see that the data spans about a 20-year time range, ranging from 1990 to 2010, and as well as the mean and standard deviation for the total number of dengue cases. So it looks like we have about 25 cases on average a week, but with a very high standard deviation. We're seeing a min of nothing up to a max of 500. So we expect this data to be pretty highly irregular. In fact, we see that the 50th percentile of 12 cases a week is actually well below the mean of about 25. So it should be interesting to plot this data and see what we come up with. As far as the features, we also see, well, first we see this error message, and we'll get into that, but we see also the similar range, the weeks, again, not particularly interesting there, but we do have the standard deviation, the means for the temperature, humidity, precipitation. Looking back at this error message, though, we see that we have invalid values for the percentile. So we're not getting percentile readings for our precipitation, our temperatures, air temp, any of this kind of stuff. And if we look actually at the count column, we can see why. So we're going over 20 years of data, so we have 1,456 weeks. However, as you can see, we do not have 1,456 data points for a lot of this meteorologic data. In fact, we don't have it for any of these other feature values. So we're going to be dealing with missing data as a problem, and so we're going to have to figure out what to do with those values, especially if we want to make predictions or get any sense of the percentiles. So in the coming days, we'll be looking at ways to different methods for imputing values into these missing data fields and how to deal with that. But that's all for today. Come back tomorrow where we'll be going over the CRISP-DM DevOps process as well as the background business understanding for this project.